this video, we're going to have a look at two types of symmetry, reflection symmetry and rotation symmetry. This figure has reflection symmetry because it falls back exactly on itself when it is reflected in the axis of reflection. The line is called the axis of symmetry. This shape, or even graph, also shows reflection symmetry. For an example, draw all the axes of symmetry for the shape below. I can see that this shape could reflect about a vertical axis of symmetry. I can also see that this shape would reflect about a horizontal axis of symmetry. But there's also the diagonals. The shape could reflect on the diagonal and fall back exactly on itself. And then there's the opposite diagonal, being four axes of symmetries. Rotational symmetry. If this figure is rotated 90 degrees clockwise, about the center point, the figure will move back on top of the original figure. Suppose the points are labelled A, B, C, D. If we rotate 90 degrees clockwise, we would move down A, B, C, D. If this rotation continued, the points would relabel as such, and again, and then finally, you can see that it took 4 rotations of 90 degrees clockwise for point A to return to the original position. We say that this figure has a rotational symmetry of order 4. If a figure has rotational symmetry of order n, with n being greater than 1, if 360 degrees divided by n is the smallest angle of rotation that it takes for the figure so that it moves exactly back on itself. So in this previous example, we had 360 degrees divided by order 4, which was the 90 degrees minimum rotation for the shape to fall back on itself. In this poorly drawn propeller, it has a symmetry of order 3. I can see that it can turn once, twice, and 3 times to fall back on the original position. 360 degrees divided by 3 is 120 degrees, which should have been betterly drawn, which is the smallest angle of rotation that the figure takes to fit back on top of itself.